Thanks everybody. Thanks everybody for joining. Thank you for letting me know. I just kind of adjusted the presentation just based on the audience, so we all get the most value out of it, and we avoid Zoom fatigue as much as possible. But the nice part is, I'll do my best. I'll monitor the chat, and if you got questions, we can speak up and answer as much of those during the process. So thank you all for joining today. My name is Michael Carbenia. I'm the Executive Director of Career and Technical Education for ZSpace. We are an AR and VR company based out of San Jose, California. We all work remotely. I actually live in Orlando, Florida, where I was most recently the director of a large school district down in South Florida, where I had roughly 40,000 students and 62 career-themed academies. So I've run the gamut of all of these, and I was actually a ZSpace customer before I came to join the company. So with that said, this is kind of the overview we're going to cover today, a little bit of the ZSpace applications, our NOCD alignment, because I think that'll really matter because that supports all the industry credentials that students can earn with ZSpace, and then some hands-on pieces you'll see. And then the idea is that you understand ZSpace as a toolbox, and depending on your needs, you take out the appropriate tool. These are the content areas we're going to cover, so everybody will get a chance to see. We kind of specialized. We'll go a little quicker just because we won't need the full time to talk about this, but we'll get that going. So with that said, as somebody had asked, what is ZSpace? So what I want you to do is understand the technology landscape. So most of you probably know augmented and virtual reality as a head-mounted display, something called Oculus or HTC Vive. Incredibly cool. Google Cardboard is another one. Awesome, but it's a one-on-one experience where you're putting something over your eyes, over your face, and you're going into a new world. Very big in the gaming world. Then you have augmented reality, where you're just augmenting a particular space or item in front of you. So you could be putting a filter on your face and giving you dog ears or earrings, or in my case, a full head of hair, or you're making a rocket come out of the ground. Still, you're just augmenting a space. ZSpace is the combination of both of these. We actually fall into the mixed reality or XR category. We are a Windows-based device. Now, this is important to understand because I'm sure this will be the first question. You can do a desktop, which you see here with the elephant coming out of it. That's a 24-inch display. The cameras are actually inside of the hardware. Or you can do a laptop where students, it's more of a one-on-one, but the cameras are built into the monitor. So all you're actually wearing are a regular pair of glasses. a ZSpace glasses. I'm going to show you in just a minute what those look like. But the reason that's important is, just like you're doing virtual reality or augmented reality, a device is required. So let's talk about a Chromebook. A lot of people ask, can you use ZSpace software on a Chromebook? The answer is no. Chromebooks are not expensive, powerful machines. These are very cheap, designed for web browsing and using the G Suite, but very low demand. You're not running CAD programs on them and things like that. ZSpace is a Windows-based ZSpace machine we manufacture and create, and you can do all your normal Windows operations on it. So it's really designed for education. So let me give you a little clip to help make that picture come together a little bit.
Welcome to the real world of virtual reality on the ZSpace platform. What is ZSpace? It's a tabletop virtual reality that's transforming education today. ZSpace functions as your typical Windows PC until you open the ZSpace application, and then the magic really begins. Long story short, ZSpace tracks the user's eyewear and stylus in real time, allowing the user to comfortably reach in and interact, move around, dissect, blow up, or change different variables within the environment.
Awesome. So I hope that helps understand a little bit about what it is. So as a whole, just know that ZSpace is used in 2,000 school districts, hundreds of post-secondary institutions across the United States. We have over 1 million students that use us, and it's growing every day. So if you have a specific use case that you'd like to know about, I'm happy to, at the end, I'll give you my contact information, and I'll be able to speak a little bit about maybe different individual use cases. Say if you're a post-secondary person with us today, I can give you an example of what, even though we won't get into automotive today, Renton College is up here in Washington. They are using the laptops. They're in their automotive program. They're shipping them to students in this new COVID world, and then they're teaching their lessons and disassembling. So it's a pretty cool use case that, depending on what your size and what you're asking for, I'm happy to talk about that. Also, know that ZSpace has content for 12 out of the 16 federal clusters that are listed by Carl Perkins. What that really means is you just need to know we have something for everybody, with the exception of the business and finance, marketing. I think Certiport does a great job with the Microsoft bundles of the world. That's just not our area. We really focus on the skilled trades like the health and manufacturing and the IT side of it, STEM. That's really our focus. So this is a list of all these applications. We're not going to get a chance to get into all of these today, but as you have questions about them, please feel free to ask. We can do a follow-up conversation to go more in depth, because we do have some more traditional K-12 content or adult education content for my credit or non-credit rather students. We have a lot of tools for them, and I do a lot of work with some of those institutions as well. So as we're moving forward, think about the acronym DICE. What you can do in ZSpace, and this was coined by Dr. Jeremy Bailenson out of Stanford. He gave this acronym about us, and what they think about us is that ZSpace allows you to do things that are dangerous, impossible, counterproductive, and or expensive. And those are the examples we're going to talk about today. And especially in this new post-COVID world where you need a tool that it can work face-to-face, hybrid, remote, blended, we accommodate all of those form factors. Also, what's unique to ZSpace more than anybody else is that we have a partnership with NOCTI. And what that means is your students have the ability to earn 33 different industry credentials. We are the only AR/VR product that is endorsed by NOCTI in the United States. And it's a really cool piece. You'll see how it's woven all through our curriculum and our scope and sequence. This is something that we're really proud of, that students can earn industry credentials throughout the entire piece. So I'll kind of pause for a minute because we have a smaller group before I get into the individual content. Does that make sense for everybody?
Sure.
Awesome. So, and again, as you got questions, I've got the chat. All right, great question. So I think I addressed the one about ZSpace and Chromebooks. I think I got that one. Those were great. And as I mentioned, yeah, it is a specific, ZSpace is a regular PC with, of course, built-in augmented and virtual reality to it. But it is a Windows laptop. You can still do things with it. So with that first take, as I mentioned, I'm not going to get into health today or automotive because as the audience, you guys, that's not important to you right now. But if you have interest, maybe you're an educational leader and you want to talk about that, I'm happy to talk about those at a later time. So we've got mechanical fundamentals, fluid power, and pneumatics. And then we break into industrial robotics. So we'll cover all that and what that looks like. But beginning with students earning, so if you're doing a FANUC level 1, if you're mechatronics, if you're working on pre-engineering track, these are NOCTI credentials. So this is how it's aligned, and what that really looks like is you see here, this is all gargled up, but let me help make sense of it. When you talk about following workplace electrical safety, lock in, tag out, that can be done in these applications right here. When you talk about learning about proper techniques to navigate a workplace, walking around and working on surfaces, that's actually a simulation inside of here. Where when you talk about developing, testing, and redesigning prototypes, that's also done inside of here. However, when we get to things like OSHA standards, describe the role of OSHA in technical workplace, that's still something that is done by the instructor. Now, we can help make that content relevant for you, but really that's not a virtual, that there's not much value to be brought out of that. However, designing, testing, and prototyping is. We have a great customer at the University of North Texas that their textile program, they do all their prototyping in CAD programs. So I know that some of you will probably say, well, Tinkercad is too simple for me. If you use Revit or Inventor, we accept any STL or OBJ file. You can actually import that into ZSpace. And instead of your students looking at it, two-dimensionally, they can actually look at it in virtual reality. It will automatically do that because we do have a partnership with them. So any file that is an STL or an OBJ and they save that proper extension, you can bring that into ZSpace. And then you could actually 3D print from there as well, just to make that known. So what it looks like here, as you're going to see, is, sorry, it looks like I got a question. I think I got you. Great question. Let's talk about, this is the fundamentals. No matter your track, anything you're going to go into, I have high schools that use us, colleges that use us. So let's take a peek at what that looks like. So what you're going to see here, this is the mechanical fundamentals application. And we're going to cover these 5 areas, and I'm going to kind of walk through these in greater depth for you. So the first thing you'll see here is the connection. So when you go into the connection, the idea is that what you're seeing me do right now, this can be recorded using the ZSpace laptop, and I can take this video. So in a remote setting, I can talk over the video right now. We're on the left-hand side right now. You see me working with the disassembly, the couplings, or the threaded piece. Also, you can see here the feather. I can pick this up and manipulate it. I can do all of this inside of ZSpace, and I have a stylus that allows me to pick it up and manipulate it, so I can coach students through the purpose of a feather key. I can actually even start to make it come to life when I click the application. So you're seeing here, I can get it, I can manipulate it, I can have it in a sectional view, so I can teach them from this, where instead of them drawing it on paper, I can enlarge this, I can pick it up and manipulate it any way that I like inside of it. And I would just record it. It saves as an MP4. So it doesn't matter if you have Blackboard, Canvas, which I think California is going all to Canvas. So all of this would import right into your Google Classroom or Canvas, and you would just share this with your students. Or of course, if you sent the laptops home with your students, they could do this for you. I can make my own cross-cutting plane here, where I can take the cutter, go through, I can take my own entire piece, and you'll see here, I can separate it myself. So you can see the tremendous value that this can bring from teaching. Even if you're face-to-face now, I would have the glasses on, and this would be coming out of the screen at me. This would be right in front of my face, just like I'm right in front of it now, where I could turn my head and look at it. But in this remote environment, I can still do this live over Zoom, just like we're doing now. I could do it over Microsoft Teams or any of those platforms. So what you're seeing is all the little tiny consumable pieces that students wouldn't necessarily have access to in a remote world, I can have access to. So I'm able to take these, the sectional view, I can always disassemble these items. It's always available. I'm enlarging here. Every piece is always available. And it really allows a student to understand the purpose of even the tiniest woodruff key. So that's something that we're really excited about, and you're seeing here. I can pick it up and manipulate it and do whatever I want. I can go straight to the sectional view, right in between. So regardless of your content area, this is a relevant topic, and it's something I really like there. I love that super enlarged view that you can see. Also, as I'm going through it, there's other different pieces. So think about the mechanic, the student that wants to get into the industrial trades. They're going to need to understand and perform maintenance, and they're seeing how it all works, how it all goes together. So in the design process, they're also able to understand its purpose. And that adds tremendous value for somebody who, especially a visual learner, or let's talk about students for any of my secondary people that are with me today. You have students with IEPs or 504s, and you want to accommodate them. This is a different way. Threading, one of our most popular uses. You know, students all start out, I know somebody was with me, I believe it was Roger, who has a machine shop. You know, we have kids turning screws, letting them see and understand that 60 degrees, the root, the crest, These are all things that kids just think a screw is a screw. And I remember that in my manufacturing program. The first thing they always started out to do was make a different screw. And they're turning that right there. So it's a great visual representation. We teach them the basics, like righty-tighty, lefty-loosey, just because sometimes no matter how you are, if you're adult education or you're doing some reskilling or upskilling, this is all a great way for them to get visual representations. So very workforce friendly as you're training. And you're just seeing that going through. Then we can get into things like couplings, and we teach them about the different variety of couplings that exist. And of course, I can manipulate it. I can stress it so they can see what happens when it does that. I can go into my sectional view, and you're seeing I'm just enlarging it here. Go into the sectional, I can explode it so you can take it apart and see how everything connects. I could pick up just the flange. Hey, look, here's the flange. And you can even, we get into details, you see those threadings in there. And that's something I think is really cool for students to see. It really helps make things relevant for them. And of course, you can move it in any way that you like, and you have complete control of your space. And I can't stress enough, you're seeing this on a ZSpace. That's the magic of ZSpace. But if you had the glasses on in front of you, it would actually pop out and you would see it as if it was right in front of your face. So then after that, then we go into the mechanism. And I think this one's really cool because this is the kind of stuff that students are not going to have access to in a remote world. So they're able to go through and look at different machine pieces, and they're starting to able to understand. Up on the right, there's always a little definition of what it is, and you're able to see how it works and how it functions. And again, it can always be exploded and taken apart, even the most simplest piece of it, and you can see how it works. And we just noticed that it really helps elevate and push. You know, we give them some more relevant, realistic models of what they're seeing. You know, CAMs, and that covers a lot of different industries. We, as I mentioned, we do have a standard automotive, but we know that this is something that could be relevant for them. And you can pull all these pieces apart, and then I can look at them individually, and that's what you're seeing here. I can look at the valve, I can look at the tie rods, I can look at anything that you like. And it's all be easily picked up with a stylus. I can manipulate it any way I like. And you get into the planar 4-bar. This is one that I really, really like because I think the visuals that this gives you in teaching students is cool. Of course, internal combustion, all the different stampings. We're giving you all these fundamentals. And that's the idea. I know it's a lot, and you're kind of consuming a lot of this right now, but the idea is that you understand there's a lot of things, information available for you. We have everybody that uses us, and the idea is that you have access to something that you wouldn't traditionally have access to. And you can go through the process and understand how all of these are impacting the entire. So they would have learned about all these individual pieces as they go through it. As you get into the planar 4-bar, we also do a little thing where we kind of give them some Jedi sneaky math. So you see here, you get to see how the diagrams work, and they can understand the points of dead center and how pi is important in circumference. And they're getting a chance to see resistance and friction. And you can talk about it in a different way, that they're not staring at a piece of paper, or that you can do this remotely. Because as an instructor, I could record this video myself, and I could talk over it for my students so they know what I'm doing or what we're talking about in this new world. I could do this as a live lecture if I wanted to. And that's something that's really cool as you're going through it. So I know that's a lot. If there's, let me check the questions as you guys keep watching this for a minute. I see a couple questions. Yeah. Yes. Any, Gary, any STL or OBJ you can view right like this you're seeing now. You can put it right into ZSpace. That's a part of ZSpace Studio, and you can do that. Yeah, Julio, I've heard that a lot, unfortunately. You know, Chromebooks are great tools. I think they're great for standard education. They're awesome. You know, for the CTE application world, I think it's a little different in kind of the needs and demands that we have. But that's where, even if your students have Chromebooks, we have districts that are purchasing ZSpace to record your lessons. So even if just, I'll give you an example of actually in Texas. So he had 26 CTE teachers ranging in the health to automotive, manufacturing. They all have the laptops, and they're working from home, and they're recording the videos just like you're seeing now. So they're making these videos and they're putting them on their LMS, and the students will watch these videos and then have Google Hangouts about the videos and what you're seeing here. They're doing all of that. Still, the students will have Chromebooks at home. The teachers will have the laptops so they can record themselves and do it that way. So you're getting a chance to see the purpose of what. So I understand it's quite all right. It's just the world we're in. It's a lot different now. So again, these are just things from the logistics side of it. We always want to stay relevant. So this is all building because students are understanding how things go together and what the purpose they play as we continue to build. Because once they've got it, there's a lot of different chain gears and belts. Because the idea is once they've got it, we go into now it's time to get some hands-on, so some fluid power, because you're still going to need to move things. So what's really cool here is the same concepts you just saw, where the working principle here, I'm seeing how this vane pump runs. I'm watching the fluid move through it. If I have an additive manufacturing application or program, here's the pump body. I can understand how that whole mold injection works. I can pull it all together. I can take it apart. I can also do the sectional view again. So we keep the themes of engineering and manufacturing very consistent. Sorry, I took a drink there. The perspective view is one of my favorites, where you're able to just make a particular part transparent. So you'll see that there, that they can also take it and go through the different pieces. And then hiding is exactly what it says. It's just going to be like disassembling through the different parts. So once they understand it, the next thing we do is we give them a schematic. And we say, great, there's 8 schematics for hydraulics. There's 8 schematics for pneumatics. And that is going to challenge them to build. So what you'll see here is the students will actually demonstrate mastery building, because we know in this new remote world, they're not going to have a pneumatic system at home. They're not going to have hydraulics at home. So here's the schematic. They can build it and they can still get that hands-on feeling that they would not be able to traditionally get. So you have the relief valve and you're going here. It's highlighted in green because you're placing it on the field and it's the correct item. So now I got to go to a solenoid, my two-way, two-position solenoid. I've got it here. I can put it in. Then I got to have an actuator. I'm a single acting actuator and I'm going to drag that down. And then after that, I've got to have a T-joint and my accessories. So I'm building that and I'm putting it in here. So then I'm going to go run my hose. So now that I'm going to got this, I'm going to run my hose. I'm taking it through. And that's what you're seeing me do here is I'm building this. And then they're still getting that experience. And what's cool is that it forces them to do it correctly, but then you can see how hoses are crossed and it's not necessarily clean. And that's by design. We want them to understand where you place and how you build is important. And if you think about back to the schematic, it's designed. And here you turn it on and you can actually see the actuator moving. And that's a really cool feature. So we do that in pneumatics and hydraulics. Both of those go together. So I will pause for a minute. I see a lot of questions popping up. Let's see here. How fast are updates? Well, hardware, we've been using the all-in-one for 12 years. We just update the guts. We have people that have been using the same ones for 12 years. And then the laptop is about 2 years old. So, well, of course, we continue to upgrade our hardware, but you don't need to buy new hardware just because we come out with new software. We're not like Apple, where your apps will stop working if you don't buy the newest piece of hardware. Yeah, the students will build and they will design and then assemble them. That's all in the process. So the students can design and build a system. Yes, that is a right. You got it. Perfect. Great question. So we're going into the robotics side, where the idea is that this is really designed to prep them for, again, being an industrial maintenance tech. But if you wanted to get into the PLC, we do have a PLC application that is coming out at the end of the month, where they can actually build a factory and go through logic, or one of the many, 5 or 6 different programming PLC languages that they are. when they're going to have access to using an HMI and how that builds in. It's a really, really cool application, and I'm happy to show you that afterwards at another time. So when we get into our industrial robotics, we broke it into 3 sections. The mechanical structure of the actual robot, because remember, this is about maintenance, and because that's a high career, high demand job. The control system, they'll actually get a chance to use the teach pendant. And then the sensing system, which is going to reflect the need for them to understand programming and the PLC element. So we get into sensor basics, the internal sensors, the externals, infrared, barcode reading, a number of varieties. And this is all readily available on ZSpace.com. You can download these right on the website. Easy to find. Up at the top, it says education content, and you can find these. I just wanted you to see the depth that these go to cover that. So with that said, this is a little peek at what it would look like if you're looking at schematics. You can see here how they would be the robotic arm. This is modeled after a FANUC, but if you had things like Festo or KUKA, it's still relevant for your students. We just happen to have a very large number of FANUC users that get that. So but we have others. We're working on others constantly. So here's a little quick clip of what it looks like using the teach pendant. So you see that teach pendant, they're going to be able to come over and use their log key. So they start to understand, oh, this is a 5-axis, 6-axis, and they're rotating it and they're manipulating that all inside of it virtually. Things they would never, ever do at home, but in a remote blended world, it's going to be really valuable for your students to see this and to understand. That way, once they do come back, they'll actually have some ground rules of what they can do. So after that, we get into the safety training and periodic maintenance. So you'll see here, this is a quick clip of them actually getting into the industrial robotic disassembling process. So here's the principles. And once they get into it, I'm going to see all the parts so I understand how they work and how they function. And it's teaching them, how if they're going to program, you need to know what element you're programming in your ladder logic. Or if you're doing maintenance, you're doing the monthly or quarterly maintenance on this, you need to know how that servo is going to need to be serviced. I can go into the structure of it. I can look at individual pieces, and that's what you're getting a chance to see here. Things that they would not have access to, I can pick it up, manipulate it, I can turn it, I can look at that servo, and I can see how it interacts. So there's, of course, disassembling too, where you can just take it apart. So you think about if you're even basic project lead the way or some of that, you just want kids to get exposed to this. It's really cool that they can take apart these robots and they can have access to this regardless of the setup that they have. So I'll pause, take a few questions. Otherwise, you guys are moving along. Okay. So I know I had some people here with some ag. I don't want to leave off one of my favorite content areas, my ag mechanics. So we have an application called Vivid Science that covers the botany. So your cash crops, your livestock, those are all inside of there. You can see all these for the fetal pigs. Those are all inside of it, even microbiology. So we do have things like coronavirus. It's actually been around a long time. But you can dissect E. coli, a lot of the food, bloodborne, airborne pathogens, that's all inside of it, and they can dissect it. But what's really cool is what you're seeing here, where you can take something like a simple 4-stroke engine. So even if you're in a manufacturing side or ag mechanics, they get a chance to look at that 4-stroke, which is a popular setup. I can turn it on over here at the bottom left. I'm actually going to start to turn it on, and then more importantly, I can enlarge it, I can manipulate it, pick it up, something that would be impossible. And if I want, I could take the crankcase off, and I'm actually going to be able to see that all work on the inside. So it's a really powerful, super awesome use and visual for students. Then if I'm done, I can flip over and I can go grab a cow, and hey, what do you know? I can start to take apart a cow. So you're going to see here, oh, I can start to get into the anatomy, because comparative anatomy is always big in ag. And so here you are taking apart, I can zoom in and say, oh, did you know the cows have multiple stomachs? And they can go through it in different capacities. So a lot of our ag community really enjoy this. It's a diverse enough program that it lets you really cover a lot of content areas. Also in ag, we do have welding. I think what's different from us is I love Lincoln and Miller. I think those are great products because they are actual welders. Our case, it's really about letting students who get an entry level that have never done it. So again, they may have some IEPs or 504s. They may need some upskilling. They may be adult education. We want them to have the opportunity to weld. And our focus is on the 4 fundamentals of speed, distance, trajectory, and angles. So the student will have the opportunity to practice these 4 and get immediate feedback. So they don't need to worry about burning up materials. The instructor doesn't need to monitor them, and maybe they never get through safety, so they never get the opportunity to weld. We want them to have the opportunity to do that. So here, these are your different options. We do stick welding and MIG, or torch welding. So when they go through it, they select their different ones, and then they will actually begin to weld. So the blue torch is the correct position. This is what the student did in the transparent position, and then this is all the data that they did. So this explains what they did, how they did, and all this is stored in a system called Vulcan. So you can access this at any time. So students could do this anytime you want. And that's a really cool way to monitor and give them some support. That way, when they do get into welding, if they make it through safety, they'll have the opportunity to weld. It's also a very cost-effective way in the grand scheme of welding. So as I mentioned, Tinkercad, I just wanted to make, because we had enough questions about it, you can go on Tinkercad right now, sign up for a free account, pick up something. And in this case, I get a valve for a water. On the right-hand side, you can do this. You click send to. You're going to see the option to send it to ZSpace. And when you send it to ZSpace, it drops it right in. Why that's important, because I have a lot of people who will just import as well. Import their STLs or OBJs inside of here, make some quick changes, and then you'll send it right to it. So that's a really cool feature, a relationship we have with Autodesk that we're really excited about. And that's just some screenshots of what that would be like, where I could grab it, manipulate it, disassemble, could have worked together to make that. So I know that was kind of fast. I want to give you my cell phone and my email address. So if you have any more questions, again, we didn't cover the health, we didn't cover automotive, just because of the group today. But if you have questions about those, please reach out. I'm happy to do a follow-up conversation with you or any of your peers that you may have questions about. But that's my contact. And we have 8 minutes, so I can take questions or I can give you back some time. Checking question. Awesome. Yep. Thank you very much. And again, that's it. Really high level. If you want more, I can put my contact back over there and answer it again. And I'm happy to do a deeper dive. If you have your instructors or your teachers, or you want to know more, there's a ton of information on our website. But I'm happy to help you in any way. So thank you all. All right. So what I'll do is I'll put my contact up one more time, just so you have it. And thank you. Otherwise, just drop off, and you guys have a great rest of your day.